Just across the waters from Athens, a quiet peninsula hides a dangerous secret. This is Methana, a seemingly tranquil landscape of sunlit hills, coastal villages, and steaming hot springs. But beneath its calm surface lies an active volcano, still connected to the forces deep within the earth. For centuries, it has been silent, but now that silence is beginning to fracture. Gases are seeping through the ground. Subtle tremors are echoing beneath the peninsula. And slowly, almost imperceptibly, pressure is building once again. Methana is not extinct, it is dormant, and history has already shown what happens when it wakes. Because this volcano has erupted before, and the signs suggest it may be edging closer to doing so again. Methana's deceptive calm is rooted in a much larger and far more powerful geological system. The Methana Peninsula forms part of the South Aegean volcanic arc, a chain of volcanoes that stretches across southern Greece and includes some of the most well-known volcanic systems in Europe. This arc exists because of a slow but relentless collision deep beneath the Earth's surface. The African plate is being forced underneath the Eurasian plate, sinking into the mantle in a process known as subduction. As the African plate descends, it heats up and releases fluids into the overlying mantle. This lowers the melting point of surrounding rock, generating magma that begins to rise toward the surface. Over thousands of years, that magma has found pathways through fractures in the crust, creating volcanoes along the arc, including well-known systems like Santorini, Milos, and Nisyros. Methana marks the western edge of this volcanic chain. Unlike the classic image of a steep volcanic cone, Methana is a complex volcanic field dominated by lava domes. More than 30 individual domes have formed across the peninsula, built from thick, slow-moving lava that piled up rather than flowing easily. This type of lava, typically andesitic to dacitic in composition, is highly viscous. It does not allow gas to escape easily. Instead, pressure builds over time, sometimes leading to sudden and violent eruptions. The landscape itself tells the story of this activity. Jagged hills, solidified lava flows, and fractured terrain stretch across the peninsula. Beneath it all lies a network of faults and conduits that continue to act as pathways for heat and gas. Methana may appear inactive at first glance, but geologically, it is anything but dormant in the true sense of the word. It is part of an active system, still connected to the forces that created it. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Methana's history is not buried in deep geological time. It exists within the span of recorded human civilization. The most well-documented eruption occurred around 230 BCE, during a period when the ancient Greek world was already observing and recording natural phenomena. Writers such as Strabo and Ovid described an event in which fire and molten rock emerged from the peninsula, dramatically altering the landscape. Lava flowed from the volcano and extended all the way to the sea, creating what is now known as the Kameni Kora lava field. The coastline itself was reshaped, with new land formed as molten rock cooled and solidified upon contact with the water. This eruption was not one of the catastrophic, explosive events seen at other volcanoes in the arc. Instead, it was largely effusive, dominated by the outpouring of lava. But that does not make it insignificant. It shows that Methana is not a relic of the distant past. It has erupted within human history, and it did so with little warning. More importantly, that eruption does not define the volcano's full potential. Methana's magma is viscous and gas-rich, meaning pressure can build beneath the surface and be released violently. Under the right conditions, this could produce explosive eruptions, ash clouds, pyroclastic flows, and widespread hazards. The historical eruption serves as both a record and a warning. Methana has awakened before, and when it did, it changed the landscape in ways that are still visible today. And when it erupts again, there's no guarantee it will be as quiet. Despite its long silence, Methana continues to show signs of life. These signals are subtle, easy to overlook, and often dismissed as background geological noise. But taken together, they paint a picture of a system that remains active beneath the surface. Across the peninsula, hot springs continue to bubble up from underground reservoirs. These waters are rich in minerals and heated by geothermal energy that has not dissipated. The presence of these springs indicates that heat is still being supplied from below, likely from magma that has not fully cooled. In addition to thermal activity, gases are constantly being released through small vents and fractures in the ground. Carbon dioxide and sulfur compounds seep quietly into the atmosphere, often unnoticed by visitors. These gases are typical of volcanic systems and can indicate that magma is still degassing at depth. Seismic monitoring has also detected activity in the region. Small earthquakes occur as the Earth's crust adjusts to stress and movement beneath the surface. While these events are minor, they are part of the broader pattern of a living volcanic system. Scientists from the Institute of Geodynamics of the National Observatory of Athens continue to monitor these signals, though Methana does not receive the same level of attention as more active volcanoes like Santorini. This creates a unique challenge. The volcano is active enough to warrant concern, but not active enough to command constant focus. This is what makes Methana unsettling. It isn't erupting, but it isn't truly dormant either. It exists in a state of quiet activity, where subtle changes can build, and then accelerate without warning. The real danger of Methana lies not in its size or its frequency of eruptions, but in its unpredictability. Volcanoes like Methana can remain quiet for centuries, then shift from subtle unrest to eruption in a matter of days or even hours with little warning. When they do, the impact is often amplified by the lack of preparedness. One possible scenario involves the growth of a new lava dome. Magma could begin to rise slowly, pushing its way to the surface and forming a dome over time. While this might initially appear non-threatening, such domes are inherently unstable. Gas pressure can build beneath them, leading to sudden explosions that fragment the dome and send pyroclastic flows racing down the slopes. Another possibility is a more directly explosive eruption. If gas-rich magma reaches the surface rapidly, it could produce ash clouds and eject material over a wide area. Even a moderate explosion could pose serious risks to nearby populations, damage infrastructure, and disrupt air travel. There is also the potential for localized hazards. Small earthquakes could destabilize structures, while interactions between lava and seawater could generate steam explosions or even small tsunamis. What makes this more concerning is Methana's location. It sits within reach of densely populated areas, including the greater Athens region, while the peninsula itself attracts steady tourism. In the event of an eruption, evacuation and response would need to happen rapidly. Methana may not rival larger volcanic systems, but its impact could still be significant. Its proximity, low public awareness, and unpredictable behavior mean even a moderate eruption could have outsized consequences, potentially putting tens of thousands at risk locally and, in a worst-case scenario, affecting hundreds of thousands across the wider region. Efforts to monitor Methana are ongoing, though they are less extensive than those focused on higher-profile volcanoes. The Institute of Geodynamics of the National Observatory of Athens maintains seismic networks that track earthquakes across the region, offering key insights into underground activity. Beyond seismic data, researchers monitor ground deformation using GPS and satellite technology, detecting subtle shifts in the Earth's surface that may signal magma movement below. Gas emissions and thermal observations also help track changes in the volcano's behavior. However, monitoring is limited by resources and priorities. Methana is often overshadowed by more active systems, meaning it is observed, but not under constant high-resolution surveillance. Preparedness measures in the region reflect this reality. Emergency planning exists, but public awareness of Methana's potential risks is relatively low. Many people view the peninsula as a stable and safe environment, unaware of the geological processes still at work beneath their feet. This gap between perception and reality is where the greatest risk lies. Volcanoes don't need constant activity to be dangerous, and the quiet ones can be the most unpredictable. Methana's future is uncertain, but the conditions for renewed activity are clearly in place. As part of the South Aegean volcanic arc, it is driven by ongoing tectonic forces that have never stopped. It has erupted within human history and continues to show signs of internal activity through gas emissions and seismic movement. Dormancy here is not extinction, it is a pause, where pressure quietly builds beneath the surface. The real challenge is not predicting exactly when it will erupt again, but recognizing that the risk exists. Methana may not need a massive eruption to be dangerous, and when it awakens, this quiet peninsula may prove it was never truly asleep. And when those forces reach the surface again, the world may be reminded, very suddenly, that this quiet corner of Greece was never truly asleep.